This is our final project for transport processes 2. The team members are Santiago, Abigail, and Aranza, and we will explain a steady-state molecular diffusion problem. So this is our problem. It says a petrochemical company produces ethylene and sells it as raw material for the production of polyethylene. During this process, the product goes through a distillation column that separates the water from the ethanol. The ethanol immediately goes to the next production phase, while the water goes to a treatment plant for reuse within the process. However, not all water is clean enough and therefore must be disposed of properly. To achieve this, the company developed a biogranulation process, which consists of absorbing the chemicals that are in the water, in this case ethanol. In order to carry out this proposal, the maximum possible rate of absorption of the biogranule has to be in units mole per hour. It must be first measured to define whether the proposal is viable or not, and we have determined that the value of the maximum rate of absorption has to be less than 10 to the minus 7 moles per hour. In order to solve this problem, it's necessary to explain what is happening. This is a problem of steady-state molecular diffusion, as it was mentioned, and it operates in a simple system in which the concentration and the mass flow are functions of a spatial coordinate that is spherical. We can assume that the pressure, temperature, and diffusivity are constant. Also, the concentration is limited because the biogranule can only absorb a certain quantity of the solution, that is the water contaminated and the ethanol. The problem does not mention any chemical reaction, so it's a no homogeneous reaction. These are our boundary conditions. Our first boundary condition refers to the outer layer of the biogranule, that is, the surface that first comes into contact with the ethanol contaminated water. Our second boundary condition refers to the inner part of that outer layer. In other words, is the part that delimits the body of the biogranule with its surface. So the first step into solving this problem is to set the general equation. We assume that the change of concentration respect with time is minimum and it's a no homogeneous reaction, so we can cancel those terms. And we have our final equation for spherical coordinates. The second step is to develop the fixed rate equation. These two terms are cancelled because we are only working with one substance, that is the ethanol. And so we have our second equation. So now that we have our both equations simplified, the next step is to substitute the equation 2 in equation 1. And the division is constant, so we know it's not taking into account for the integration. The next step is to substitute the first boundary condition in the equation 4 to find C2. Now that we know the value of C2, this equation is replaced again in the equation 4 to leave all unknown terms with respect to C1 and find its value, and so we have the equation 5. Later, the second boundary condition is substituted in the equation 5 to find C1. So now C1 and C2 are known values. Will be substituted in the equation 4 to be simplified and factorized, so we can have our sixth equation, that is the derivative equation. This equation refers to the phase through which the mass is being transferred. If this equation is replaced in the fixed equation, we will know what the total mass transfer is in the process. Now solving for WA, the rate absorption, we have to equalize the equation 6 and the equation 3 to get a new one that will be the 7th equation. Later, we have to substitute this equation in the fixed rate equation to obtain the mass transfer, the total mass transfer that is in the process. Then with the rate formula, we can obtain our last equation. Finally, if we substitute the given values in the equation 8, we can obtain the result. And the last thing to do is to convert them into moles per hour. So this is our final result, minus 6.258 plus 10 to the minus 7. And we can conclude that the negative sign makes reference to the direction of the process because it's going from the outside to the inside. And also, these results indicate that it can be accepted because it was what the company was looking for.